It gives me great pleasure to now introduce to you Dr. Ben Weiner from Morgan Hughes' lab, who's going to talk to you about trap, eat, kill. What's a neutrophil to do?
White blood cells are the sentinel cells of our body. They are searching for invaders in order to fight them off, but they're also critical in detecting cancer. And every day, each one of us in this room expends a tremendous amount of energy producing 100 billion of these cells, of which neutrophils are the majority. And neutrophils only last for about 24 hours. So like a good New Yorker, they have a lot to do and very little time to do it in. And like a New Yorker that's walking down the street, experiencing the sights, sounds, and smells of the city, neutrophils are constantly being bombarded by chemical and physical cues. And what they have to do is they have to sense and then integrate that information and then make decisions. And decisions about where to go, what to do when they get there, and whom to communicate with. And the question is, how do they go about this decision-making process? And one way of thinking about a neutrophil or an immune cell is as a microprocessor. And the decision-making process like a logic tree. So if you're a neutrophil starting at the base of the tree, and you start your day and you have all these different options, but you want to get to the top of the tree. You have many different routes. And as you go down a path, you have forks in the road. And the question is, what genes and processes are being made at each of those steps along the way? And if we can actually define the genes and the mechanisms, we essentially can create a blueprint of how the cell is making decisions about a particular pathogen, cancer, in a defined context. So if we can basically create this blueprint, we can develop new tools. And I am specifically focusing on signals that say, don't come here, don't eat me. And I want to leave you with one quick example. So solid tumors have been refractory to immunotherapy. But if we have this blueprint in hand, basically we can re-engineer the cells. So a solid tumor is sending out these signals, and it's including the neutrophils and other immune cells. But we can basically send our own program, override what the tumor is telling the immune cells, allowing them to innervate into the tumor microenvironment, and then tell them to kill the cancer cells specifically. And this would be basically a new way of training the innate immune system to do what we are programming it to do, adding a new tool to our fight against cancer. Thank you very much.